Picture the Big Bang in your head right now. You're likely imagining a massive, blinding explosion erupting into a pitch-black, empty room. But here is where our everyday intuition fails us. That dark, empty room never existed. There was no outside waiting for the universe to appear inside of it. The Big Bang didn't happen in space. It was the moment space and time came into existence. Asking what happened before is like standing at the North Pole and asking someone to point north. The question breaks down. The geometry of direction simply ends there. To really understand the birth of everything, we have to let go of the idea that time is a constant ticking clock sitting in the background of reality. Now imagine rewinding the cosmic clock and running the universe backward, reversing through the last 13.8 billion years. Immediately, the expansion of the universe reverses. Trillions of galaxies rush backward, crowding closer and closer together as the entire cosmos shrinks. The density spikes. Temperatures rise so high that atoms are ripped apart, dissolving everything into a chaotic, boiling soup of pure energy. If we keep rewinding, we eventually hit a hard limit. A fraction of a second after the very beginning. Specifically 10 to the negative 43rd seconds, known as the Planck time. At this exact moment, the physics we rely on completely crashes. Our equations for gravity and quantum mechanics refuse to work together, spitting out mathematical infinities. People often call this point a singularity, but physicists see those infinities as a massive error message. It is a signal that our current scientific models are incomplete, and we are missing something fundamental. Instead of a true singularity, the beginning may be governed by a deeper theory we are still searching for. Within that unknown territory, several fascinating possibilities emerge, starting with a quantum fluctuation. In the quantum world, empty space is never truly empty. Energy fluctuates, spontaneously popping in and out of existence. The entire universe might have emerged from one of these sudden fluctuations, exactly like a wave forming out of a flat ocean. Another patch is the no-boundary proposal. In this model, time near the beginning behaves exactly like a dimension of space. You can travel across it, but you will never find a sharp starting edge. In both of these scenarios, the word before loses its meaning. The geometry of the universe is entirely self-contained. But there is a third idea, one that paints a very different picture of the beginning, the cyclic cosmos. Instead of starting from nothing, imagine an ancient, dying universe that stops expanding. It reverses course, collapsing violently inward toward a single focal point. Under this model, the Big Bang was not a beginning at all. It was a bounce, the explosive rebound from the total collapse of whatever came immediately prior. If that model holds true, then before the Big Bang was a completely different universe, one with its own history, its own galaxies, and its own unique physics. All of these theories leave us with the original lingering question. If you could stand there, what would the pre-Big Bang state actually look like? The short answer is that looking is physically impossible. For the first 380,000 years, the universe was an intensely hot, opaque plasma. Light could not travel freely, meaning there was literally nothing to see. But the deeper hurdle goes back to the birth of space-time itself. Before that moment, there was no physical location for an observer to occupy, and no light for human eyes to process. Trying to visualize the universe before the Big Bang is like trying to remember a specific memory from before you were born. The framework required to hold the experience simply does not exist yet. We live on a small, rocky planet, orbiting a very ordinary star. Yet we have built the mathematical and scientific tools to trace reality back 13.8 billion years, right to the edge where our physics breaks down. Asking what came before that edge is the ultimate marker of human curiosity. We may not have the final answer yet, but the fact that we can even ask the question proves that the origin of the universe remains the most thrilling frontier of discovery.